Okay, here's another statics practice problem. This is similar to one of your homework problems, but I've tweaked it a little bit so it looks different. Specifically added this extra bar here. But that's neither here nor there. Let's see how we can solve this. We're going to assume the structure is weightless and we want to find the reaction forces at A and B. Actually, all we're going to do is we're going to write the equations that would let us solve for the reaction forces at A and B. Okay, so of course the first step is to create the free body diagram. So we take the structure apart and we just show the forces. All right, so there's a pin at A, and so we mark point A here. There's point A, and we have a reaction force vertically and horizontally because it's a pin. And of course, B is a roller ball, so there's only a vertical force. Okay, and we know our units here for the forces are pound force. That was already given in the diagram. Okay, so we want to solve for the reaction forces. The method is sum of forces in the x direction with moving to the right being positive. Okay, so I look and I see an AX, but there's no other horizontal forces, so pretty easy. AX is equal to 0. Okay, now sum of forces Y referenced up. Okay, so I see I have a force AY reacting at the pin. Okay, that's moving up. I have a negative force of 300 pound force, another negative force of 100. I'm going to drop the units for writing the equations. Okay, counterbalanced by B moving up equals 0. Sum of forces in the y direction. Okay, so we have at this point two unknowns, one equation, so we're going to need sum of moments. All right, so you can do that about point A. That's easy enough since there's two forces there. Actually, AX is equal to 0, so it's 6 of one, half dozen of the other, as to whether you use point A or point B. So let's go ahead and use point A and do counterclockwise as positive like we always do. Okay. So let's consider this 300 pound force acting down. Let's change the color here. 300 pound force acting down. What is the moment generated? So remember, we can look at lines of force and we find the perpendicular distance. Okay, so that perpendicular distance is 3 feet, and this is acting down. So this moment would be a force acting down, causing a rotation that would be clockwise. So this would be minus 300 times 3 for that moment. Okay? Then we have a force acting down again at 100. Again, you take the perpendicular direction, and that distance is 2 in this case. I didn't draw that very accurately, but the distance shown is 2. Okay, I guess really I'd need to move this over a little bit to be more accurate. Okay, so again, that's creating a clockwise rotation, so it's minus 2 times 100. All right, and then I have the force B. Okay, so we look at A, move this perpendicular line. B, you move it up to here. I can tell that moment is going to be 3 plus 4, which is 7. Okay, remember this distance 3 is to the center of pin A, same as the distance 2 here. Okay, so just to clarify that. But anyway, this would be 2 plus 4 is 6 times B, and it's going to be counterclockwise, so that'd be a positive rotation. Plus 6B is equal to 0. Okay. So at this point, we have written the equations, and I think we know what to do. From this equation, you can solve for b. Once you know b, you can substitute that back in here and solve for a.